Hi guys, my name is Sophia and this is my week 14 reading video. So in week 14 we continue talking about electromagnetic radiation, i.e. radiative electric fields that arise from accelerating charges. But in this week's videos we focus on a special case where particles oscillate, which means that they speed up and slow down as they just move back and forth. So suppose we want to measure the radiative electric field from a charged particle at a particular observation location. The radiative electric field will point perpendicular to the position vector from that particle to the observation location. And so you can use the perpendicular component of the particle's acceleration to calculate this radiative electric field. As a result of the particle's oscillation, we will get an oscillating electric field and an oscillating magnetic field, and they will be perpendicular to each other. And both the electric and magnetic field will be perpendicular to the direction of propagation. And so we also learned about the period, wavelength, and angular frequency and regular frequency of oscillating E fields and EM radiation. So yeah, and specifically the propagation, the speed of propagation, which is the speed of light, is equal to the wavelength times the frequency. Yeah, and finally we learned about the interactions of EM radiation with matter. When EM radiation hits an object, some of the radiation will be reflected off the object, but then some of it will actually be absorbed by the object. And this object can then re-radiate some or all of the radiation that it absorbed. And the direction of the E field of this emitted radiation will be opposite to the direction of the E field of the incident radiation. And maybe the same thing is happening with their magnetic fields as well, but the video didn't really talk about magnetic fields. So I already knew some of this week's material from the previous week. Like, for instance, I knew about the direction of the E field and B field and propagation of the EM radiation, and I knew that only accelerating charged particles can produce EM radiation. But in this week, I specifically learned about a new model for accelerating particles, which is oscillation. And also the whole relationship between the speed of light, frequency, and wavelength is kind of a review from Gen Chem, where we talked about this same exact relationship in the context of light emitted by electrons falling from an excited state to the ground state. And finally, the concepts of emitted radiation were familiar to me from previous engineering classes, where we classified objects as either black bodies or gray bodies based on the amount of incident radiation that they emit. And something that I found difficult was when Dr. Schatz was writing up all those formulas at the beginning of the video for the E field, the perpendicular E field, using the perpendicular component of the acceleration. I wasn't really sure where all those sines and omegas and phi's came from, but after rewatching the video a few times, I finally started following where Dr. Schatz was getting all those parts of the formulas from, and how the sine actually represents the oscillation and the path of the charged particle. So yeah, after that I was good, I think. And I want to go into the medical field, so EM radiation is of particular importance to me because doctors use different kinds of radiation for all sorts of applications, like X-rays, PET scans, and even light microscopy for histology. So it was kind of an interesting topic for me. Well, that's it, folks. Thank you so much for watching my week 14 IE final video for the semester. I hope y'all have a great day.